Unit 9, Lesson 1, Solving Radical Equations. After this lesson, you should be able to solve for the missing variable in an equation that includes a radical, also known as a square root. First up, let's review those inverse operations. Since we are solving equations, make sure we do the inverse operations when solving them. First up, the opposite of adding is subtracting. The opposite of multiplying is dividing. And the opposite of square rooting is, you guessed it, squaring. And that's what we're going to be looking at today. Doing the other inverse operations first before we get the radical by itself, and then we're going to square both sides. Speaking of those steps, here they are. First, move all numbers outside of the square root. First by adding, subtracting, then by multiplying, dividing. Then undo the square root by squaring both sides. Then solve what is left, because you might have to do a little bit more work, or you could be done. Let's look at our first example. Number 1, 2 times the radical x plus 1 equals 5. So we have the steps to solve right over here on the right-hand side for us, just in case we need to look at those again. But remember, the first step was to get everything on the outside of the square root. So first add, subtract, then multiply, divide. So we're going to draw our line. We want to get this radical by itself is what we're doing first. So we want to move the positive one by subtracting 1 on both sides. Write down what we have. 2 radical x is equal to 4. Now continue to go on, and let's divide by the 2 since it's being multiplied here. To get the radical again by itself, this is what we're trying to isolate, so it sometimes helps to box it. Now we have the square root of x equals 2. We're almost done. We just got number 1 done. We moved everything on the outside of the radical, so the radical is by itself. Now we're going to undo the square root by squaring both sides. And we just draw parentheses around each piece and square them. This square is going to cancel out the radical, which just gives me my x is equal to, and 2 squared is 2 times 2, which is 4. And you're done. Now, we do solve what is left if we have more to solve. And all we have was x equals 4, which was already isolated and solved for. Number 2. Same idea. We're actually going to have, I'll work this one out. Let's pause it. So again, we're trying to move everything away from the radical first. So we're going to box it in. We're going to basically isolate it, is what this is talking about right here, by getting everything away from the radical. So we're going to minus 9 over, since that's the opposite of addition. We now have 3 times the radical x equals 27. Then this 3 is being multiplied by here, so we're going to divide by 3. Again, we want to get the radical x by itself. So now we have radical x by itself, which is good, is equal to a positive 9. Then, of course, undo the square root by squaring both sides. So now we square it, because now the radical is by itself on that side. It cancels out the square root, which gives us x by itself is equal to 9 times 9, which makes 81. All right, 2 down. More to go. Here we go. Number 3. So again, steps to solve are always the same. We're going to move everything on the outside of the square root first. So I'm going to box in my whole square root. It's a little bit bigger now. And I want to get everything on the outside away from it, which means this negative 3 that's being multiplied here, we're going to need to undo it by dividing both sides by negative 3. Now we get radical x minus 2 is equal to positive 7. Now, the radical is by itself. There's nothing on the outside of it on either side of it. So now we're going to undo the square root by squaring both sides. Remember, the square only cancels out the radical. So then we're going to get x minus 2 is equal to, and 7 squared makes 7 times 7, which is 49. Then, this is what it means to solve what is left. Because our x is not by itself. First off, we got to move this negative 2 over by adding it. And I believe that's all we have to do here, because now we have x by itself is equal to 51. Awesome possum. Here we go. Keep trucking along. Number 4. Now this one's very unique, and you're going to see why here in a bit. So first off, again, the steps to solve are again to isolate the radical. So let's get this by itself by adding or subtracting or multiplying, dividing things over. So first we're going to minus the 15 over. Now we have 3 times the radical of 5x minus 4 equal to negative 21. Continue, and then, of course, get the radical by itself. If it's not yet by itself, we have the 3 that's being multiplied, so let's undo it by dividing both sides by 3. Now we have radical 5x minus 4 is equal to negative 7. Now, this is where we need to talk about possible solutions that are extraneous. That word is this, and I'm going to write it down here. Extraneous. Means we do have an answer if we solve, because we can find one, but if we were to plug it back in, it will not be a solution. And that's because if I look at this right here where we're at, we have this radical equal to a negative 7. There is no possible way for us to take the square root of any type of number and have it be negative, because the square root is always a positive number when we take the square root of it. So this right here lets us know our answer is going to be extraneous, which means it's not going to actually work out for the equation. But we can still continue to solve it, which we will. So we'll still square both sides to get the radical gone. So now we get 5x minus 4 on the inside. Negative 7 squared is 49. We're going to continue to solve for x by first getting the 4 over by adding 4. And then after that, we're going to, of course, divide by 5 to get the 5 by itself since it is being multiplied. And we get x equals 53/5. Now, if we were to take this answer and plug it back in for x here to see if it makes this statement true, it won't, because of this situation right here. It is considered extraneous. So our solution is also considered extraneous. And it's good to know about this because you'll learn more and more about this in Algebra 2. So let's continue on. Number 5 is going to be the same thing. It's going to be an extraneous situation. I can see it already, but let's just go through it and try it and get it and see. So we're going to isolate the radical by getting it by itself. So move everything over to the other side by first adding or subtracting and then multiplying or dividing. So first we're going to subtract the 1 over. Now we have 2 times the square root of x minus 4 equals negative 14. Again, this 2 is being multiplied, so we're going to undo it by dividing, because again, we want this radical to be by itself, and it's not by itself yet. So now we have radical x minus 4 is equal to negative 7. Again, this right here is another instance of where this could be an extraneous solution, meaning it's not going to work out if we plug x back in for our solution. So we can still continue to solve it like we did before by, again, squaring both sides because the radical is by itself now. That's going to cancel out the radical. We get x minus 4 equals 49. And then continue to solve for x by adding that 4 over. And we're going to have now x equals 53. And again, this is an extraneous answer because of that situation we had when solving. And if we were to plug this 53 back in here, we would get this to be 49. The square root of 49 is 7. 7 times 2 is 14, but 14 plus 1 is 15, not negative 13. And that is why it will not work. All right. Number 6. I think I've done plenty of these. This one is for you to do, so go ahead and pause this video and try this one out now. Pause. Correct answer here is 26 for x. All right, this one was definitely a doozy. It had a lot of work. We still, even after it, we squared both sides. We had to solve what was left, and now is this steps right here. So if you can do this one, you are golden, and you are awesome. If not, keep working at it. You'll get there. I know you can. So let's do another one together. Number 7, we'll do this one together, and then we're going to have you try out some more on your own. But here we go again. We're going to isolate the radical x. We're going to get it by itself by first moving that negative 5 by adding it. Now we have 4 times radical x equals 24. This is being multiplied by this. We still got to get this radical by itself. So since the 4 is being multiplied, we're going to divide both sides by 4. We're going to get, there we go, radical x is now equal to 6. Since it's by itself, now we can square it to get rid of the radical. That's going to cancel that out, which now gives us just x equals 6 times 6, which is 36. Bam, that one wasn't too bad. Awesome possum, moving along here. Number 8, you know what? This one is for you. So go ahead and pause this video and try this one out, please. Pause. And there you have it. X equals 49. Not that bad at all. 2 more to go. Here we go. Number 9. You know what? We're going to do one more together, and you got the last one. I'll do this one with you. So again, we want to get this radical by itself. It's not by itself. We got this -5. We got to move over by adding it. Then bring down what we have. Radical 2x minus 3. Make sure you have that all underneath the radical because it is equal to 10 plus 5, which is 15. Now the radical is by itself, so we undo it by squaring it. Remember, there's nothing on this side, nothing on this side. That allows us to do this now. Then we got to square 15. Yuck. I got to get my calculator for that. I think I know what it is, but I'm not sure. Square is going to cross out the radical, so we get 2x minus 3 left over. And 15 squared, I believe, is 225, but let me just find out for sure. And it is 225. My brain was right. Continue to solve. This is what it means to solve what is left after you've done step 2 and 1. So we got to get the x by itself, so we're going to add 3 first over to both sides. Now we have 2x equals 228, if I did that right. And then now again, the x is still not by itself because 2 is being multiplied, so we're going to divide both sides by 2, and x is going to equal, I believe, 114. And let me just double check my math. 228 divided by 2 is definitely 114. Awesome possum. That's all there is to it, people. Number 10, the last one. This is yours to do for all the marbles, whatever that means. So go ahead and pause this video and try this one out. Pause. And there you have example 10 all worked out. First had to add a 20 both sides, then divide by 4 to get the radical by itself. We squared both sides. That gave us x plus 3 equals 25. Then just solve what was left by minusing the 3 over to get the x all by itself to equal my grand old age of 22. There you go, people. If you have any questions, please make sure you raise your hand and let us know. If not, go ahead and do some perfect practice problems on those awesome Google Slides, and we'll take the quiz shortly. Have a great day.